questions 21 through 25 on the 2018 Grade 8 AMC 8. How many positive 3-digit integers have a remainder of 2 when divided by 6, a remainder of 5 when divided by 9, and a remainder of 7 when divided by 11? Well, if the number, let's call it n, has a remainder of 2 when divided by 6, we can write n minus 2 over 6 is equal to an integer, and we'll just call that integer a. If the number has a remainder of 5 when it's divided by 9, then we can say n minus 5 divided by 9 is an integer, and we'll call that integer b. And similarly, n minus 7 over 11 we'll call c, since the integer exists when n is divided by 7, and the remainder, n is divided by 11 and the remainder is 7. Okay, so these equations give me the following. N is equal to 6a plus 2. This one gives me n is equal to 9b plus 5. And this one gives me 9 is equal to 11c plus 7. So we have to now play around with these guys, and it shouldn't be too bad. The first one, let's see here. I guess I just equate those two since they're both equal to n. 6a plus 2 is equal to 9b plus 5. So that means 6a is equal to 9b plus 3, and therefore divide through by 3, 2a is equal to 3b plus 1. All right, that's the first relationship. I want to get another one between b and c, and that means 9b plus 5 is equal to 11c plus 7. 9b is equal to 11c plus 2. Okay, well, at this point, let's make a very nice table, and let's see what we get for our values. And this takes a little bit of math, but it's actually not too bad because there's a little bit of a pattern. So first, let's concentrate on this guy right here. We want to get integer solutions, right? So when you kind of work through it, the first one that you get, a, b, and c, and then of course our n, is 8. When c is 8, that's the first time it'll give you an integer solution. But unfortunately for a, it gives 5.5. Once you get the value for c and b, you plug it back into here to get a. The first time you get an integer solution for all of them is with 17. 17 for C gives me a value of 21 for B. It gives me a value of 32 for A. So that works. And then you plug any of those back into any of these equations up here and to get the value for N. And that one would give me 194. So as you can see, that's the process. And the pattern actually is when you go up each time by 9, you get an integer value for b. But unfortunately, it gives a non-integer value for a. So you go up by another 9. And when you go up by another 9, it gives an integer value for b and an integer value for a. So again, sub it into any of these equations, and n will be 392 in this case. So now that it's a pattern, it's easier, right? You don't have to go 36, 37, 38. It would take forever. Just go up by 18. And when you do, you get 53. And you plug that into here. And that gives me 65. Plug that into there. And that gives me 98. Substitute that into there. And I get 590. And in a very similar way, there's a couple more. 71. We went up by 18, basically. 87, 131. And then for n, it's 788. And then there's one more 3-digit number. Because remember, we only look for 3-digit numbers. Go up by 18 there. Then this will be 109, 164. And n is calculated to be 986. So 1, 2, 3, 4, 5. 5 values that satisfy the conditions of the question. Therefore, number 21, the answer is E. Point E is the midpoint of side CD in the square ABCD, and BE meets diagonal AC at F. The quadrilateral AFED is 45. What is the area of ABCD? A couple of different approaches to this question, really, but what I'd like to do is put it on a coordinate axis. And when you do that, I think it makes it easy. Well, let's allow me to illustrate why. Really, what we're trying to do is figure out the equation of this line and then this line. Once I have that, I will be able to find the point of intersection, which is right there. All right, well, let's give some values here. Let's call this A, let's call this 2A, and then this, of course, will be 2A, and then this point is 2A, 2A, like that. So the equation of a line, as always, is y equals mx plus b. And let's see which equation we want to do first. Doesn't really matter. Let's do this equation first. So substitute in 2 points. First substitute in A0. And when you do, you get 0 is equal to AM plus B. And then substitute in 2A, 2A. And we get 2A is equal to 2AM plus B. Subtract both equations, and that gives me AM is equal to 2A, and therefore M is equal to 2. Great. Then we substitute it back into one of these to solve for B, and when you do, you get 2A plus B, and therefore B is equal to minus 2A. So our equation is y is equal to 2x minus 2a. That's this line right here. And then we have this line, that line, in the very same way we figure out the equation. We substitute in, this is 2a0, and this point actually right here would be 0, 2a. So substitute in either one of those. Let's put in the 0 for the x first, so that gives me y is equal to, well, y is 2a. So y is equal to mx plus b. Substitute in this point. So when x is 0, y is 2a. Therefore, b is 2a. And then we substitute in the other point, this one. When y is 0, x is 2a. And then b we know is 2a. So solving for this, we get minus 2a is 2am, therefore m is negative 1. So that equation is y equals negative x plus 2a. Now to get the intersection point, which is right here, we set this equal to that. So that means 2x minus 2a is equal to minus x plus 2a. So that means 3x is equal to 4a, x is equal to 4a over 3. And substitute that into either one of these, either this one or this one, to get the y coordinate. And when you do, you get y is equal to 2a over 3. So that means this f has coordinates 4a over 3 and 2a over 3. All right, so we are now ready to solve. They told me that this section right here is 45. Well, that is really just the big triangle minus this little guy. So that means that ADC, that triangle, minus EFC is equal to 45. Well, ADC, well, that's pretty straightforward. That's just half of the square. So it'll be 1/2 2a times 2a. And then EFC, this is the height, this is the base, right? Well, the base is just going to be a, so 1/2 base times height, and the height is the y coordinate of this point, so that's 2a over 3, and that equals 45. All right, so this gives me 2a squared, right? And this gives me a squared over 3. Yeah. and that equals 45. So doing this math, I will get 5a squared over 3 is 45. So that means a squared would be 135 divided by 5, 27. All right. So now we have to figure out the area of ABCD. Well, ABCD, that's just going to be 2a times 2a, which is 4a squared, which is 4 times 27, and that is 108. So number 22, the answer is B. From a regular octagon, a triangle is formed by connecting 3 randomly chosen vertices of the octagon. What is the probability that at least one of the sides of the triangle is also a side of the octagon? Well, the strategy here in my solution is first, let's find the triangles that have no such criteria, meaning here's such one example, this vertice, and this vertice, that would not have a side that is also a side of the octagon, right? That's what I'm going to figure out. And then at the end, I can just subtract it from 1 to get the probability that at least one of the sides of the triangle is also a side of the octagon. One such example would be that. Whereas you can see that is a side of the triangle and a side of the octagon. So first we'll figure out P, and then at the end, the answer will be 1 over P. 1 minus P, sorry. Okay, so let's use a frame of reference here. Let's say this is the frame of reference, that guy. We'll just call it A. And of course, B, C, D, E, F, G, and H. So we're starting with A. And that is fixed, so there's only one way of choosing an A. Now the next one, remember, I'm doing it in a way so that no side of the triangle is a side of the octagon. So I cannot choose this or this for the next vertice. But I can choose any of these guys. And there's 5 of them, so there you go. Now my third vertice, what is the scenario there? And it's not as simple because there's different scenarios. So what we have to do is look at each of those scenarios. So this system, which is what you normally do, kind of falls apart. But no problem, we can easily do it by counting. So let's say the first one is A. The next one, remember, it can only be one of these 5 because we can't have this or this, because if we did, the side would be the same as a side of the octagon, and we don't want that because we're calculating P. And at the end, we want that, so we will find 1 minus P. Okay, here we go. So the first one is A. Let's make the second one C. Second vertice. If the second one is C, then what about the third? Obviously, I'm not going to be choosing B. Can't choose D. Can't choose H. But I can choose E, F, or G. Those are fine. So as you can see, E, F, or G. So that's 3 ways of making a triangle. Well, let's keep going here. AD. If I have A and D, can't choose C, can't choose E, but I can choose F or G for my third vertice. So F or G, we got 2 there. And then similarly, AE, we can choose C or G. That's 2. If I have A and then F, I can choose D or C. That's 2. And if I have A and G, I can choose C, D, or E as my third vertex, and that's 3. When you add these up, 3, 2, 2, 2, and 3, you get 6 plus 6 is 12. All right. But keep in mind that this scenario was all for A. A is the leader here. As you can see, we can do the exact same thing for B as the leading vertice, and then C as the leading vertice. So that 12 has to be multiplied by 8, because there's 8 vertices that could be the first. And for each of them, we would get the same scenario. All right, so I hope that makes sense. Okay, now we're ready for the probability, P. It's going to be 8 times 12 over the total. The total is 8 for the first choice, 7 for the second choice, and 6 for the third choice, regardless of conditions. That's the total. So this is the probability. So this just looks like it boils down to 12 over 42. Yeah. Okay, so now the answer to the question is 1 minus p, because 1 minus p is all the ones that have at least one side of the triangle being also a side of the octagon. Well, 1 minus 12 over 42, and that looks like 30 over 42. And if you divide top and bottom by 6, we get 5 over 7. Therefore, D is the answer for number 23. In the cube A, B, C, D, E, F, G, H with opposite vertices C and E, J and I are the midpoints of FB and HD respectively. Let R be the ratio of the area of the cross-section EJCI to the area of one of the faces of the cube. What is R squared? Well, for the sake of simplicity, let's give this cube sides 1. And therefore, we want the area of the cross-section EJCI over the area of one of the faces. Well, one of the faces, if the sides are all 1, the face will have the area of 1 times 1. So this is really just EJCI. That's really all we have to do, figure out that area. Okay, EJCI, what shape is that? Is it a square? After looking at it, I think it's a rhombus. And an area of a rhombus is calculated as the first diagonal multiplied by the second diagonal divided by 2. So I got to figure out this diagonal, then that diagonal, and then I should be done with the question. And then at the end, don't forget to figure out R squared, because this is actually representing R. It's representing the ratio, and then at the end we have to square it, which shouldn't be a problem. Okay, let's figure out R1 and or D1 and D2, these guys. Well, D1, I think that is the easy one from J to I. That's just the distance across. It's going to be identical to B to D, looking at that. And B to D can be easily figured out using Pythagoras. So JI is the same as BD, and then therefore BD squared is equal to 1 squared plus 1 squared, right? Using this triangle as Pythagorean theorem. So BD squared is 2, so BD is root 2, and therefore JI is root 2. Okay, so that one is not so bad. So that's the first diagonal, so root 2 goes in here. Now I got to figure out the second diagonal, and that second diagonal is from E to C. Okay, I think that's going to involve a couple. I'm going to draw, yeah, that is going to involve this one, this triangle. So whereas this is the right angle. Okay, well, that is what, CE. So CE squared is AC squared plus EA squared. And CE squared, therefore, AC squared is a diagonal, so it's going to be root 2. Yeah, just like BD, it's going to be a root 2 of that flat square base. So root 2 squared. And then EA, that's just a side, so that's going to be 1. That's just 1. So CE squared is 2 plus 1, therefore CE is root 3. Okay, that was our second diagonal. So D2 is just root 3. Okay, and that's over 2. So this becomes root 6 over 2. So R was root 6 over 2. Now they want me to figure out R squared. So that's just root 6 over 2 all squared. And that's 6 over 4, which is 3 over 2. And therefore, number 24, the answer is C. How many perfect cubes lie between 2 to the power of 8 plus 1 and 2 to the power of 18 plus 1 inclusive? 2 to the power of 8 plus 1, and then 2 to the power of 18 plus 1. In between these two, how many perfect cubes? All right, so we've got to figure out a way to do this without using a calculator. I think that's the challenging part, but let's just see. 2 to the power of 8 is not that big of a number. It's 256. So 256 plus 1 obviously is 257. Now we've got to find perfect cubes. So we've got to find numbers that when you take this cube of it would fit in between 257 and this gigantic number. Okay, well, what is this number here? Well, I think the strategy is not to figure out that number. The strategy is to figure out the cube, the cube root of it. For example, if I were to figure out the cube root of 257, now I don't have a calculator with me, but I know the cube root of 216 is 6. I'll just put that up here. That I know. And I also know the cube root of 343 is 7. So the cube root of 257 is probably 6 point something. I have no idea exactly, but let's just say 6.3. So that means 7 cubed, 8 cubed, and so on will be in that range, ... Okay, so I got the first part of the range. Now I got to concentrate on the second part of the range, these numbers down here. Well, just like how I did up here, I'm going to use that strategy. The cube root of 218 plus 1, like, I don't like that plus 1. I'm just going to try to figure out the cube root of, sorry, these should be cubes. This should be a 3 there. It's not a square root, it's a cube root. The cube root of 218, well, that's easy because it's just 218 to the power of 1/3. And that is just 2 to the power of 6. And 2 to the power of 6 is just 64. So the cube root of 2 to the power of 18 plus 1, if I had put in that plus 1, will be ever so slightly larger than 64. So it would be 2 to the power of 18 plus 1. If I took the cube root of that, it would be like 64 point, I don't even know, 0.1 perhaps, something like that. So that means if I go all the way up to 64 cubed, it would be fine. It would be still within that range. Remember, we got to find numbers greater than 6.3 and smaller than 64.01. And those have to be integers. So 7 to the power 3, 8 to the power 3, all the way to 64 to the power 3. So there you go. So basically all the numbers from 7 to 64. So that's 64 minus 6, which is 58. 58 numbers. And therefore number 25, the answer is E.